Alrighty. I want to start by apologizing. For some reason in that last video, my computer decided to shut down. So this will be a continuation of lesson 7.3, and I'm just going to go straight into the examples. So we'll look at number 1. And it said we needed to find out what the coordinate was when s equals pi 6. So what you need to do is if you have your unit circle memorized, which is the goal here, you need to realize that pi 6 is located right here. And it's the same thing as 30 degrees. Since I'm closer to the x-axis, remember there's 3 fractions you need to know, my x value would be the larger value. So that'd be the square root of 3 over 2 and 1/2. Also knowing that I'm in the first quadrant tells me that they are both positive. So that is the coordinate that it's looking for. So these questions are just, do you have the unit circle memorized, or do you still have to use the unit circle to get these answers? The goal is to do it without. All right, let's look at another one. So let's look at number 2. It says S equals 225 degrees. Again, hopefully you're like, all right, 225 degrees has to be in the third quadrant. 225 is 45 degrees more than 180, so that puts me right here at 225 degrees. You don't have to necessarily remember the radiant measure, but if you know that's 45 degrees, then you know that's pi fourths, and then pi halves, 3 pi fourths, pi, 5 pi fourths. All right. Again, the question wasn't asking for the radian, but if you could have that memorized, you're on the right track. Again, this right here, they're the same distance from the x and the y axis. So that tells me that both coordinates are going to be the same, which will be the square root of 2 over 2 and the square root of 2 over 2. But since I'm in the third quadrant, that tells me that they're both negative. There's your coordinate there. All right, let's do another one. Let's look at number 3. This is S equals negative 120 degrees. Remember that negative means clockwise, right? So 120 degrees is going to be 30 degrees past this point here, right? So this was originally, so this is negative 120. This was originally 270. So if I'm 30 degrees before that, that's the same thing as 240 degrees, which is then the same thing as 240, that would be 30. So that would be pi 6, 2 pi 6, 3 pi 6, 4 pi 6, 5 pi 6, 6 pi 6, 7 pi 6, 8 pi 6, which comes down to 5 or 4 pi thirds. Again, if you remember that first quadrant, you can always extend it. Again, you don't have to know the radiant, but it definitely helps with your memorization. All right, in this situation, again, I'm closer to the y-axis, so that would mean that the y-axis would be the square root 3 over 2, and my x-axis is 1/2. But again, because I'm in the third quadrant, both of them will be negative. Regardless if this is a negative or positive, it all depends on where does this terminal side fall to get to that coordinate. So this is the same thing as if I would have even asked this question here, or if I would have asked this question here. Any one of those 3 questions would have resulted in the same answer because they all land in the same spot. All right. In the next set of questions, they actually give you the coordinate and they want to know they want to know all the values that fall in between it. And so I'll tell you what that means here in a little bit. So they have negative 1 over square root of 2 and negative 1 over the square root of 2. So what you have to do first here is you need to rationalize this. So when I rationalize it, square root of 2, square root of 2, square root of 2, square root of 2. So this gives me negative square root of 2 over 2, negative square root of 2 over 2. When you look at this, I hope that you easily are able to go right here. Right? This right here is the negative square root 2 over 2, same distance from both. And that's going to be 45 degrees from 180, which is 225 degrees, or another pi fourths from pi, which will give me 5 pi fourths. Either way you get there, that is the answer. Now, it doesn't, so what does it, it doesn't specify degrees or radians, but I believe on your homework they want radians. So your answer is 5 pi fourths if it says it just wants the answer between 0 and 2 pi. But in this case, it says it wants all of them. So the only thing you have to do when it says this is add in 2n pi. And this will be for all n's that are integers. So what this means is yes, 5 pi fourths is the answer, but a circle goes around and around infinitely many times. So if I go 2 pi counterclockwise many times, I'll still keep getting the same answer by doing 2 times 1, 2 times 2, 2 times 3. If I want to go 1 time, 2 times, 3 times, 4 times, and then we say integers because it can be negative. Maybe I go clockwise 1, 2, 3, 4, 5 times. And regardless what that answer is, it will give me those answers as well. So if it's looking for all, you're going to have an infinite amount of answers. Not that the answer is infinitely, but you'll have an infinite amount. But if it specifies between 0 and 2 pi, then we can just conclude that that is the answer. Let's look at another one. Oh, and I did not label it, but this is number 10. The next one I want to look at is number 11. Number 11 states 1/2, comma, negative square root 3 over 2. When you're looking at this, hopefully you're saying, all right, that's positive and a negative. That's got to put me somewhere in the fourth quadrant, a positive and negative. And then you can see I'm closer to the y-axis than I am the x-axis. So that's going to put me here. So that means I'm going to be 30 degrees from 270. So that's going to tell me that's 300 degrees, right? And again, you could use the pi 6 concept. So again, that would be pi 6, 2 pi 6, 3 pi 6, 4 pi 6, 5, 6, 7, 8, 9, 10 pi 6, which would be the same thing as 5 pi thirds. All right, so however you want to look at it. I like to use the sixth. You can use the thirds as well for all the 60-degree marks as well. All right, but there's your answer. So that'd be 5 pi thirds. Again, it's looking for all, so then you just add in 2n pi for all n's in the set of integers. All right, let's look at some other questions. Let's look at number 30. Number 30 says determine the reference angle associated with the given angle. So here's theta equal to 9 pi halves. We need to figure out where 9 pi halves falls. Pi halves is at 90 degrees. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. That actually falls right here. And it doesn't matter how many times it kept on going, it's all going to be about where did it land. So I might have gone around, I don't know what that is, 4.5 times around the circle, but that is where I landed, all right? So regardless, your reference angle is always going to be between 0 and pi halves. So therefore, this is my reference angle, or technically, this is my reference angle. Both of those are going to equal the same thing, and their reference angle here would just be pi halves itself. All right, and there you go. So you just kind of figure out where you land, and then just determine what the 0 to pi halves angle is to the x-axis. The closest x-axis. In this case, again, they're both the same. All right, let's look at a different type of problem you'll be looking at. Let's look at number 44. Number 44 says determine the quadrant in which the terminal side of the angle is located. So that terminal side's that where the line ends up. We are told that sine theta is greater than 0 and tan theta is less than 0. All right, so what we need to know, sine theta is like my y. So y is greater than 0. So that tells me I have to be in the first two quadrants. Now, tan is less than 0. You need to know that tan is the same thing as y over x. And if it's less than 0, one of those has to be a negative. But since y is a positive, that would then mean that x is less than 0. So then that tells me I'm now in the second quadrant. I think that's all we had to do. Determine what quadrant you're in. You'll be in the second one. All right. So those are the kind of questions you kind of go through to figure out where you would land as well. Just make sure you understand your signs and stuff like that. All right, next type of questions you'll see are questions like number 63. It says we'll rewrite an expression in terms of the given angle's reference angle, and then we're going to evaluate the result using a calculator and rounding our answer to 4 decimal places if necessary. We might know the exact answer as well. So we have sine of 9 pi halves. All right. And so the reference angle, we did this earlier, right? That'd be 1, 2, 3, 4, 5, 6, 7, 8, 9 pi halves lands me right here. So the reference angle can be here or it could be here, but we know that's going to be pi halves. So what they want you to do is basically kind of rewrite this and say this is the same answer as sine of pi halves, which it is. And so therefore that sine right here, that coordinate is 0, 1. Sine is the y value, so the answer here is 1. Okay? So they just want you to use your reference angle to help you answer this question. Let's do another one to make sure we got this. So we'll look at number 64. It says cosine of negative 60 degrees. Negative means I'm going to go clockwise. So 60 degrees would be about right here. So this is negative 60. But our reference angle are always measured with positive numbers. So this is, even though it's negative 60, my reference angle is cosine of 60 degrees. Right? Now, the next thing you need to determine is cosine's my x value. Is this a negative or positive for my x value in this quadrant? And hopefully you say, all right, well, quadrant 1 and 4 for cosine are positive, so therefore this would actually be the same answer. So at cosine of 60, we know that the quadrant would be 1/2 comma square root 3 over 2 because this coordinate is closer to the y-axis. So therefore, we then can determine that the answer is just 1/2. Right? So they're just having you just basically just rewriting it using the reference angle. Had this been like an answer over here, then I would just put a negative or something right there because then that's where I would fall. With that said, let's do another one. Let's do number 65. All right, 65 says tan of 5 pi fourths. All right, so again, we're going to rewrite this using the reference angle, but I got to figure out where 5 pi fourths is. So the pi fourths, that's 1, 2, 3, 4. 5 pi fourths is located right here. All right, tangent, so that means that 5 pi fourths, that's a 45-degree marker, same distance. So this right here, the coordinate is going to be negative square root of 2 over 2, negative square root of 2 over 2. And then the reference angle right here is going to be the same as tangent of, again, pi fourths. All right. Now, the thing about tangent you need to know is here it's negative and negative. So I would divide my y over my x. So I would know I would get a positive 1. But the same concept happens over here at pi fourths. It's still going to be the square root of 2 over 2 divided by the square root of 2 over 2. In these two spots, I still end up with a positive answer. So that means that this guy is the same as this guy, which is the same thing as 1. All right. So just things to look at. Again, if I was over here, then I know the answer would be negative, depending on what you're dealing with. All right, so those are using reference angles to help you get the same type of answer. Again, the idea is to get everything in that first quadrant. If you got the first quadrant memorized, then you can find all your answers for the entire circle. And that's just its goal there. All right, so let's look at number 77. All right, number 77 says use the appropriate identity to answer the following questions. Choose only one answer per question. So it's a multiple choice question. It's even a multiple choice on your homework. It says which is equivalent to sine of 18 degrees. Best way to go about doing this is determine if the relationship to tangent, cosine, cosecant, and all those. So when you're looking at those, you're going to want to look at your identities that we have. So for starters, we'll start off with our co-function identities. And we know that cosine theta is equal to sine of pi halves minus theta. Okay, so we can do a little backwards here. First, let's turn 18 degrees into radians. So that'd be pi over 180. So that would just be that 18 goes into 180 10 times. That's pi tenths, right? We'll leave it in terms of pi. So if I want pi tenths to equal this guy, I can hypothetically say pi halves minus theta is equal to pi tenths, right? This is what this would be. So I'm going to subtract pi halves. So I get negative theta is equal to, if I multiply this by 2, and multiply this one by 10. Actually, I could just multiply that one by 5. Hold on. Your least common denominator is 10, not 20. So this would be 5 and 5. So this would be the same thing as pi tenths minus 5 pi tenths. That's the same thing as pi halves. So that would give me negative 4 pi tenths, which is the same thing as negative 2 pi fifths. And then if negative theta is equal to that, positive theta must be 2 pi fifths. So we'll stop there. And we now know that sine of 18 degrees would be the same thing as cosine of 2 pi fifths. Do we see that answer? We do not. They're all in degrees. So let's then take this and convert it into degrees. So again, that'd be 180 over pi to figure out what that answer is. So I can see that the pi's would cancel. And so it's going to basically be 180 times 2 divided by 5. And that's going to be 72. So then this is the same thing as cosine of 72 degrees. Do I have that answer? I do. It's going to be option B. Now, the next alternative step here is if that wouldn't have shown up, is to then go to our reciprocal identities and look at cosecant. And then we would go on to our quotient identities. Can we connect this to tangent using multiple different functions? So we start at one identity and then we just kind of progress down until we find our answer choice. All right. So a little bit of pre-work and stuff to do here, but definitely a fun little process of solving for our theta. All right, the next type of problem I saw on y'all's homework was number 94. And it said express each of the following in terms of the appropriate co-function and verify the equivalence of the two expressions using a calculator and round your answer to 4 decimal places. So you're given tangent is equal to negative 105 degrees. You're asked to write it in co-function form. So co-function form, we'll write it over here as our little side work, is cotangent theta is equal to tan of pi halves minus theta. So we're going to do the same work here, basically, to do what we to get our answer. So again, I have negative 105 degrees. I need to convert that into radians to be able to plug it into this. So that's going to be pi over 180. I like to keep this in terms of pi. So 105 divided by 180 is 5.333. Okay, 105 divided by 5 gives us 21. 180 divided by 5 gives us 36, still divisible by 3, so that'd be 7 pi over 12. And I believe that's the same thing, 7 divided by 12. Yep. Okay. So there's our simplified. Again, I recommend this way because it'll make your math easier with fractions in the long run. So this means that this is the same thing as tan of negative 7 pi 12ths. Right? That's the same conversion. All right. So with that said, that then this negative 7 pi over 12 has to be equal to pi halves minus theta. So I'm going to subtract pi halves on both sides. So I get negative theta just like last time. 12 is your least common denominator. So that'd be negative 7 pi 12ths minus 6 pi 12ths. And so that looks like that gives you negative 13 pi 12ths. But that's what negative theta equals. So positive theta must be 13 pi 12ths. So therefore, our answer must be cotangent of 13 pi 12ths, right? But the issue on this type of question, it actually wants the degree with it. So now we just got to take this. Let's see where we're at. That's what that equals. More side work. Take our 13 pi over 12. That's 120. And we're going to convert it back into degrees. So that's 180 over pi. Pi's would cancel. Let's figure out what that answer is. So 180 times 13 divided by 12 gives me 195 degrees. So this is then the same thing as cotangent of 195 degrees. Okay, and there you go. So again, just using cofunctions to find out what the exact same answer of this is written differently, right? Same answer. And I think there's one more type of problem. That's it. Okay, let's look at number 102. It says use the given information about each angle to evaluate the expressions if possible. If no angle with the stated properties exists, determine the reason. So we are given that cosine theta is equal to the square root of 12 over 4. We know tan theta is less than 0. That's what negative means. And we were asked to figure out what is theta for starters, and then what is tan theta as the second question. Okay, so first of all, I'm going to simplify this to see if it falls on my unit circle. Again, hopefully you see that this is 4 and 3. This is our perfect square. So this becomes 2 square roots of 3 over 4, which then just becomes a square root of 3 over 2. All right, square root of 3 over 2 is one of the fractions you're asked to memorize. And that would mean that that happens here and here because the x-axis is positive. So that happens here and here. All right, but then it says tangents is negative, right? So since tangent's negative, this is positive over positive, this is negative over negative. These two spots are where tangent's positive. So that means that this one is the answer I need for tan theta to be negative. Well, that right there would mean we're 30 degrees from 360. So that would mean that theta is equal to 330 degrees. Now, I believe yeah, I think it takes the degrees. But if it didn't, you just convert that into radians. And again, this right here would end up being 11 pi over 6. All right, so I don't think it matters degrees or radians. I think it said degrees on the homework. I can't remember. But regardless, you know both. So you've now found theta. Now to find tangent of 11 pi 16ths, or 11 pi 6, sorry, or 330, however you want to write it. That would mean that this is going to be the coordinate of square root 3 over 2. That's what our cosine is, and 1/2, but negative. So this is y over x. So this will be negative 1/2 over the square root 3 over 2. We're going to keep the first fraction, change the multiplication, flip the second fraction. The 2's would cancel, leaving me with negative 1 over the square root of 3. We then rationalize this. So this gives me negative square root of 3 over 3. There you go. Again, you can do that with also with 330 degrees. It gives you the same concept. Let's do one more, and then that will pretty much conclude y'all's video here. So that'll be number 103. At this time, it says, given that cosecant of theta is equal to 1.25, And the terminal side, which is where the angle lands, of theta lies in the second quadrant. All right, so we're somewhere right here. All right, so again, given that cosecant's this, and terminal side of theta lies in the second quadrant, determine what is cotangent of theta. All right. All right, so cosecant, again, so hold on one time. Cosecant's this, the terminal side lies here. Okay. For starters, let's write this as a fraction. I know it's going to be somewhere in this area. I don't know where, because this right here is, what was that, 5/4? Is that right? Or, yep, okay, so that's the same thing as 5/4. All right, so cosecant is the inverse of sine. Sine is opposite over hypotenuse. So hold on, we got to do some work here. Let's call this theta right here. So this is theta. Cosecant, again, is the inverse of sine. Sine is opposite. Here's hypotenuse. Here's adjacent. So it's opposite over adjacent, or opposite over hypotenuse, but with cosecant, it will then be hypotenuse over opposite. So this would be my 5. This will be my 4. All we gotta do is figure out our A. So what we're gonna do, because cotangent is the opposite or the inverse of tangent, so that is, so tangent opposite over adjacent. So cotangent would be adjacent over opposite. So I need to know that adjacent to have my answer. So here we go. So that's going to be 4 squared plus b squared equals 5 squared. So 16 plus b squared equals 25. Subtract 16. B squared equals 9. Square root of that, we get b equals 3. The famous 3, 4, 5 triangle. All right, so therefore, once I have that answer, I can then determine that this will be a 3 and opposite of 5. Now, the part that states that it's in the second quadrant is important because things in the second quadrant means that the x value is negative and the y value is positive. So this ends up being a negative 3/5. So that whole point of it being in the second quadrant is important. That tells us what our sign is going to be. All right, and that's pretty much every type of question I could see. Oh, my bad. That's the opposite, adjacent over opposite, which is 4. All right. But that's all the questions that I saw on this homework. If you end up needing any more help, just let me know. Until the next video.